like?
How many line segments will be needed to create step A of the sequence?
Let's see. What are options? 10. So bonus number 1. How many line segments are there in the first step 1? 2? How about step 2?
6.
Step 3?
18.
Does everybody agree with that? Don't sound right.
I got 14 and 30.
So that'd be a total of 20, right? Is that right?
No, just 14. 2, 6, 14.
I'll go 2, 6, 14.
Pardon me, teachers for the. Good morning.
Step 4.
Today is November 17th. Today is Brown Day.
You guys see a pattern?
Pledge.
Double one adds 2.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
So doubles and adds 2. I can do this.
Playing baseball. Open hitting starts November 17th in the high school gym from 6:30 to 8 o'clock. If you have any questions, contact
I know this one's 20. If I drew it, or not 20.
This week
30.
is National Hunger and Homeless
If I drew it
Awareness
out.
Week. Did you know that most requested item in homeless shelters are socks? Please
If I
warn
know the same
socks.
thing here.
Having cold, wet
This
feet
is
also
doubling.
leads
So how many is the
to
next
other
one
health
gonna
and
have?
medical problems. If you need any information or resources, please see Ms. Workman in the guidance hallway.
Double that, what's it gonna add?
The National Trail Role Playing
Add
Society will
32, so it'd be
continue their
62, right?
campaign.
I know, but I was asking a different
After
question.
school until 3:30 today and Friday. If you have any questions, please see Garland
Step
Weaver,
6.
Leland Miller, Jonathan Sturgill, or Mr. Bright.
So how many is it
That
gonna
is all I
add this
have
time?
for today. Thank you and have a great day.
How many is it gonna add this time? 64. Logan up here trying to be cute, answering the question I'm not asking.
I can't do that math.
How many is the next one gonna add? If that added, let's see, somebody add that for me.
250.
Step 8, I think that's the one we're looking for, isn't it?
Yeah.
256.
Gonna add 256 to it. What's that give you?
310. Wait. Down.
510?
Huh. And you counted it wrong.
No, I just didn't count it right, yeah.
Thank you.
I don't know if this is sort of relevant, but it does go to 2640 in lower numbers.
Say again?
2640.
Oh, on the end? Yeah, until you get to this one, that doesn't, that changes.
Yeah.
Remind me, and I'll give you that one.
Hmm?
Remind me, and maybe I'll give you that one. Other questions? Other ones you want to see? Okay, not the 2 column proofs.
18.
Read it to me.
We're not 18. It's sequence.
Let's start off with 2 dots, then 6 dots. Is that right? Then what?
12 dots.
4 going across,
Yeah.
3 lines of them. So what's the next one gonna look like? This one was cross 3, down 2, cross 2, down 1.
Add a row to the side and add a row to the column.
So this one's gonna go down 4 and across 5. How many is that gonna give you? 20. Next question, while you're looking, I'm gonna do this one real quick because a lot of people miss this, but trying to find me another problem here. One of them said like sufficient and insufficient. And you can find it on there if you want, but I want you to know this rule. How many things you have to show to prove something is true?
A lot.
A lot, all of them. right, so is one sufficient to show something is true?
No.
How many counterexamples, or how many things do you have to show something is not true?
One.
One. So is one sufficient to show that something is false? Yes. Make sure you know that. Only takes one thing to prove something wrong. Takes a whole bunch to prove something is correct. Other questions?
Did I get a point off for my cat handwriting? Was it just that
I think it was supposed to say not, and it doesn't look like it does. It looks like,
I do.
no you don't, you got is.
Then it's, no, it's.
Remind me and I'll give you back that point. Not sure why I should. That's, I got bad handwriting, but can you read my writing up here all the time?
Yeah.
Either of those.
You guess what? I didn't.
I get it from my dad. I never knew handwriting was genetic, but
Other questions?
I can prove you wrong. Prove you wrong.
Thought you wanted to see that angle problem.
My dad has really bad handwriting. My mom has.
Number 2, what's it say?
Good handwriting,
A rectangle is a
Bad
parallelogram
handwriting.
before writing.
but it's better than my dad's. So that's when my mom. It's bad.
Only
It's
those
really
that I
bad.
got wrong.
So, the reason you got it wrong, it didn't make sense, and if it was bonus, I wouldn't give you credit.
Just call it.
So, it says what again?
A rectangle is a parallelogram before writing.
So, if shape is a parallelogram,
Yeah. With 4 right angles.
I'm sorry, if a parallelogram is a rectangle, so if a parallelogram is a rectangle, then what do we know about it?
That's four right.
It has 4 right angles.
So basically just switch the word rectangle to parallelogram.
And if you switch it around, you say if a rectangle is a parallelogram.
That's what I wrote, Logan.
Well, all rectangles are parallelograms, so that right away doesn't make any sense. Parallelogram could be a rectangle, so this is the order it's got to be. You don't want to see the angle
No, you already screwed that done wrong.
I meant to do. Any other questions? Do me a favor, get out a clean sheet of paper. On that clean sheet of paper, you're going to draw that picture and put number 1. Draw that picture and put number 1. Go ahead. I'm not going to tell you anything about what we're getting ready to do, but this will be handed in. May be helpful to you. Is this why we're happy when Grant's absent all the time?
I'm more happy about Duff and Cooper being.
I completely agree.
Yeah, but Grant's sort of trying to take their place, I think.
Yeah.
Now James.
When I seen them all yesterday morning, Jameson, they were saying, it doesn't matter, you still got Jameson. Jameson didn't give me any trouble. At least not since like the first 2 weeks when you being a knucklehead about putting stuff online. All you really need to do is draw the picture. We're going to go through, we're going to do this, you're just going to copy down stuff. I cannot write on this very well, so it's not gonna look very good, so you're gonna have to write it as we say it. First segment, given information, says segment CE is congruent to FE. So over here in my picture, what am I gonna do?
CE is congruent to FE.
So I put,
The lines.
put a little mark on each one. See, that's what it's gonna do all the way through this. So just put a little mark on each one of those. Then they tell us segment ED is congruent to EG. So what am I gonna do on that? Put 2 marks. Can't put just one. Ignore those. Put 2. Now, just from that given information, if I told you segment FE was 2, what do you know about segment CE? That's supposed to be a 2. If I told you EG was 5, what do you know about segment ED? What can you now tell me about segment FG and segment CD? They're congruent. They're both how long? 7. What are we trying to prove?
CD is equal to FG.
Trying to prove that those two are the same, right? Is it going to work out that way every time, no matter what numbers I put in there? Yeah. This segment added to this segment is always going to equal this segment added to this segment if these two are the same and these two are the same. So we should be able to go through and do this. What's this first reason? They gave us all the statements. What's the first reason?
Given.
And again, it's going to look ugly, so you better be listening. What do we do to go from 1 to 2?
Definition of congruence.
Definition of congruency. I was going to make it. Step 3, statement 3 says CE plus ED equals CD. CE plus ED equals the whole thing. Segment, addition, postulate. Whatever I write up here, that's about as short as you can get it. Let me change that. However I write it up here, that's as short as you can get it. All right, period. Because I got people on the test doing this when they're doing segment addition postulate. If you're that lazy that writing those 4 extra letters is going to just kill you, please go down and talk to the counselor and get out of my class. Because it's just silly. You got to be able to write something. That's just sort of. Next one, this is one that a lot of people missed. Is that one segment addition also?
No, it's substitution.
If we look right here, it's saying segment FE plus segment EG. FE plus EG, but it says it equals segment CD. All they did on this one, if we look back up here at number 2, they told us that CE and FE were the same. So they took out CE in this one and stuck in FE. They took out ED and stuck in FG. So what is it?
Substitution.
Substitution property. I would probably, if this wasn't one of these fill-in ones, I probably would have done the next segment addition right after the first one, just to make more sense to everybody. But, and somebody else did this one. Now look at number 5. How they know that this segment plus that segment equal FG?
Segment addition postulate.
This one's segment addition postulate. just to answer any questions as we go throughout the year, all these little stray things like this. Sometimes it just does it at random because I try to write too fast. This, it's doing it because this is a picture and it doesn't like to write on pictures. Look at what we have in 3, or no, I'm sorry, in 4 and 5. You notice anything? You can still read that. They both have all that on that one side, right? So if those two things are the same, what's that tell us about the two things on this side? They're the same. So that's what we're going to do here. What property did we use again? Substitution property. Took out something, stuck something else in its place. It's spelled right. Quit looking at it, Logan. What did we do to go from 6 to 7? Definition of congruency. And I'm going to do this. Don't do this on your paper. I'm going to do this. Definition of congruency. Just because I don't, it's going to do the same thing to me and give all those crazy lines going up. Fill it in there on your paper. So everybody see the reasons that we use? Have we ever used those on anything else before? No, never ever used any of them ever before. This is brand new. They all get used over and over and over and over again. That's why it killed me. Some of the tests, I had people sticking stuff in here like, what did they? I'm trying to think of something that they stuck in here. That 4 and 5 here. Can't remember what, a lot of people stuck in different stuff over there for the reasons. And I'm like, yeah, we said that in class, but we never used it for a reason for anything. Write this down on your paper there, number 2. Grant, how are you not burning up with that sweatshirt? All you guys, man. I'm roasting. I can't. It's like it's hot here today and I can't breathe. What's our first column? Second column? What's our first statement going to be? Given? What is that? I'm confused.
2 parentheses 3x minus 5 other parentheses equals -4.
How do we know that?
It is given.
Some people are still doing the work in the 2-column proof. Don't do that. Make sure, and Miranda, I understand that yours, you draw in the lines and stuff, so I know which ones match up, but just be on the safe side, number them both. What's the next thing? What am I going to write down?
6x minus 10 equals -4.
And what do we use there?
Just leave it
Please, again. I'm writing it about as short as you can write it and it makes sense. Let me change that. I'm writing it as short as you can possibly write it and it makes sense. I had somebody on one test put D property. Really? And then they're probably going to be mad at me because I marked it wrong. What's the next statement?
6x equals 6.
How do we go from 2 to 3?
Sufficient property of equality.
Please make sure, a lot of people forgot that of equality, that's gotta be on there. Addition property is just saying you just added something. Addition property of equality means you did it to both sides. And what's the last statement gonna say?
X equals 1.
And what's our reason?
Division property. Oh.
Yeah, Ebersole makes you feel better, you just put division rules.
I'm not sure why that would make me feel better. Just write down, stupid. Just draw the picture and put number 3. Did you spell it S-T-U-P-I-D? Did you spell it S-T-U-P-I-D? She had to have me repeat it because she didn't know what I spelled. That's what you get for laughing at me all the time.
It's your fault.
What's the first piece of given information tell us?
Q is the midpoint of PR.
So from P to R, Q's the midpoint. What's that telling me?
That splits them into 2 concurrent segments.
So what are the congruent segments?
PQ and QR.
Segment PQ and segment QR. So let's mark those. Ignore that straight mark going up through there. Somewhere in our proof, we're going to have to say it. This segment and that segment are the same. What's the next piece of given information tell us?
R is the midpoint of QS.
So R is the midpoint of this segment from here to here. So what's that tell us?
QR and RS is congruent.
So how am I going to mark our RS?
1
Two
line.
marks.
With 2 marks or 1?
1.
One because, yeah.
If I mark it with 1, then what do I know about all 3 of these?
They're all the same.
And are they all the same?
Yes.
Yeah. What are we trying to prove?
That PQ is congruent to RS.
Didn't we just say that?
Yes. But they don't trust the picture. I don't understand why. Explain to them all these letters.
What's our first statement gonna be?
Q is midpoint of PR.
Q is the midpoint of segment PR. How do we know that? Now, there's 2 different ways you could go on this. I don't care which way you go. I see arguments for both. The way I'm gonna go, we've got to make sure that we don't forget. Did we say something else about Q being the midpoint when we were looking at our picture?
Yes.
That those 2 were congruent, right? So make sure we don't forget that, because we're gonna need it here in a few minutes, but I'm gonna go to the next given, which says R is the midpoint of segment, and I'm not sure why there's not a segment symbol on that one up there, but segment QS. And that was given. Now, the reason I don't like putting all the given right away every time, because you forget stuff. We forget to go back and talk about what this meant, Q being a midpoint. So right now, let's go back and talk about it. What did it tell us if Q was a midpoint of PR?
That PQ, QR congruent.
Segment PQ is congruent to segment QR. Again, going back to my point about these reasons. We're going to write this reason many, many times throughout the year. What told us that those 2 were congruent?
Midpoints divide segment into 2 congruent segments.
Midpoint, and you can divide, splits, whatever you want. I use splits. Segment into 2 congruent segments. Ignore that stray mark. What number 2 tell us?
That QR, segment QR is correct. Segment items.
How do we know that? Probably Jameson will probably never ever use this reason again. Was that a snicker from you? You know I was lying, right? These reasons get used over and over and over and over again. Today we're going to learn about 4 or 5 new reasons. What do you notice in 3 and 4? Anything?
QR.
You got QR in both of them, don't you? Well, they both have QR in it. What do you know about these other 2 segments? So segment PQ is congruent to segment RS. What did we use there?
Substitution.
Substitution property. Oops. Is there a number 6?
No.
Not sure why I wrote it. Scared Ethan K though. Dominique, these too hard?
No.
You sure?
Kind of.
Makes you think logically and you're just not used to that?
Yeah.
Write this, draw this picture. Number 4. Draw an equal sign.
I know, but I get the school and I can't get school. It's messed up.
Does that say equal or congruent?
Here?
Yeah.
Congruent. Can't draw a tilde?
Yeah.
I can never draw that angle sign.
The what?
That angle sign. It just doesn't work out.
Mine ends up looking like a 4.
Huh?
Mine ends up looking like a 4, especially with the
When you put a 1 in front of it?
Yeah.
So
Does
total,
the proof say
Put a
3
little
is
space.
congruent to 4 and 2 is congruent to
2.
2. So what's the first piece of given information tell us?
4? Is 1 congruent to 3?
So let's mark it. Put a little arc in angle 1, put a little arc in angle 3. Ignore those straight marks going up through there. What else do we know in this picture?
1 and 2 are vertical angles.
So the vertical angles of 1 and 2 have to be congruent. So how am I going to mark angle 2?
Same way.
The same way. We don't want to put 2 in it. What do we know about all 3 of these this time? They're all congruent. What else do we know from this picture?
That 3 and 4 congruent.
3 and 4 are congruent. So what? How am I going to mark 4?
1.
Just the same way. So what do I now know about all 4 of those angles?
All congruent.
So what do I know about angle 2 and angle 4?
They're congruent.
We should be all right. This 2-column proof. What's our first statement going to say?
1 is congruent to 3.
Angle 1 is congruent to angle 3. How do we know that?
Given. Angle 1 is congruent to angle 2. Or vertical angles are congruent, whatever this thing is.
Again, Jameson, probably never ever going to use this reason again. Vertical angles are congruent. Today's probably it, and then never use it
No
again.
more. Throw it in the trash.
Confusing.
Angle 3 and 4.
What do we have? Anything that you notice here?
Angle,
They both got angle 1 in it, don't they? So what can we say? And what do we use there? Substitution property, took out something, stuck something else in its place. We could have went a different route on this, but this is the route that makes the most sense. Because now what are we gonna say next?
3 and 4.
Ignore that stray mark going up through there. How do we know that angle 3 and angle 4 were congruent?
For angles are congruent.
Vertical angles are congruent. Now the reason it made the most sense to do it this way is because now look at what you have here. You got 3 in both of those, so what's our next statement gonna be?
2 is congruent to 4.
And what do we use there?
Substitution.
Substitution property again.
So I have a question about that.
Yep.
On my test, one of the parts is marked wrong for that, and I don't understand why.
It's the bad handwriting.
It's not really wrong, it just doesn't help us with what we were doing here. Okay, so you got angle 1's congruent to angle 4 instead of this. What we really needed was angle 3 was congruent to angle 4 so that we could use those two to get to what we were trying. Now, this is true, it just didn't really help us get to where we were trying to go, the way that you went there. Now, if you would have stuck this in there somewhere, added another step, then I wouldn't have marked anything wrong. I probably just circled it and said, yeah, this is unneeded, you didn't need to put this in there. So it's almost like you put in something extra, like, you know, maybe Logan writes in her proof, she writes that in her proof. Well, I'm not gonna say it's wrong, but it's sort of unneeded for the proof. Slope and y-intercept, how do you find the y-intercept of a line? This isn't on your notes anywhere, but it's gonna be,
Triangles am I supposed to be?
that's the linear equation. How do we find the y-intercept?
Where it
Down.
intersects the line.
That's the slope.
You
Where it
count.
intersects the line.
Where it intersects the y-axis. So what's the y-intercept of this one?
Right there.
Tell me what it is. 1. So the y, oops, not -1. The y-intercept is 1. How do you find the slope? Slope is what? Somebody said it.
Rise over run.
Rise over run. So you pick 2 points that you know fall on the line, and then you do what?
Count up and over.
How much up do I go? 2. How much over? Be careful. Negative. Slope, I'm sorry, y-intercept, slope. How about the y-intercept of this line?
Nothing right now.
We have to do the numbers. Rise over run.
Could you just extend it on out?
If we were to extend it, yes.
Yeah, but like,
Now, does it extend on out?
Yeah.
Yeah, it should, it's a line. So do we know the y-intercept?
shit.
How would we find the slope? I take this point and maybe that point. How much rise do I have? How much run? How about this one? What's the y-intercept?
-2.
How about slope? If I pick 2 points on this one,
0.
Right now.
0.
how much rise? 0.
None.
And how much run? 3.
Touch the clear.
So slope is 0. For this certain line, the slope is 0, right? What's the slope of this line?
3.
Let's pick 2 points. If I got this point and I got this point, what's the rise? 2. What's the run?
0.
What's 2 divided by 0? grab your calculator.
You can't divide by zero.
Divide by zero error.
You can't divide by zero. So what's that tell us?
Nothing.
There is no slope. This one has a slope of 0. This one has no slope. You can't find it, right? Horizontal lines have a slope of 0. Vertical lines don't have a slope. What's the y-intercept for this one? It doesn't have one. It's never going to cross the y-axis, is it? Looking at this first one, how would I graph this first one? It's not on your notes anywhere.
Right 6, up 1.
We go right 6, 1, 2, 3, 4, 5, 6, up 1, put a dot. So we graph that point. What's this slope tell us to do? Probably we should do what to that slope before we start to try to graph it. So what's that tell us to do?
Down 3.
Down 3,
Over 1.
which way?
Or left.
Left, right, which one?
It's positive.
To the right.
Yeah.
So down 3, ignore that, 1, 2, 3, to the right 1. Our line is going to end up looking something like that. How would I graph this one? How?
Right 2.
2 to the right. What's this slope tell me to do? Our line's going to look something like that. About this one.
Up 9.
Up 9, somewhere like up in here maybe. Now, what do we know about that? That's the what? That's the y-intercept. So this time they gave us the y-intercept, the others they didn't. What would this, how do we do the slope?
Right 2 to right 3.
Up 2 to the right 3, but I don't have any more space up here. So what else could I do?
Down 2, left 3.
Down 2 and to the left 3?
Yeah. You have to reverse it.
Down 2 to the left 3. The line's going to look something like that. Make sure when you're doing that, if the slope is positive, your line should be going up, right? So that way you make sure you don't do it backwards. Next thing, solving systems. Last year you learned 3 different ways to solve systems. One of them was by graphing. Like on that previous slide, if I go back here, we graph one and graph the other, and where was the solution at?
Where they intersect.
Where they intersect at. And you probably love graphing, right?
Yes. Especially when your calculator does it for you.
Nobody likes graphing usually. Even when you punch it into your calculator. It's still, it's sort of difficult. Miranda likes it, that's great. I don't mind it. The other way, another way was substitution. Anybody like substitution?
It wasn't that bad.
Substitution, you gotta get one of the variables by itself, right? And then substitute all that in, and it's not that hard, but I use substitution a lot. A lot of people don't like substitution. Does anybody remember the third way?
Elimination.
Elimination.
I like elimination.
And that's what most students like, elimination.
After graph.
And that's what we'll try to use most of the time. Now, in elimination, when they're all lined up like these are, that's what we probably use. What do you got to do in elimination? If I was going to solve this system right here,
You guys negate one.
you got to pick a variable and cancel them out, right? Eliminate one of them. Pick me a variable.
X.
X. If we pick the x's, what do you got to do to get these two x's to be opposites of each other? Times it by 2? Maybe. Just 2? If I times it by 2, what's that going to give me?
2x.
It's just going to give me 2x. So I need a negative. Now, negative 2 times x is negative
Does it have
2x.
to be negative 2 or just
Yes.
negative?
They have to be able to cancel out.
Negative 2 times 2y.
Oh, yeah. That's it.
What is it? Negative 4y. Negative 2 times 2. Once you have that, I'm trying to get out of here. Good enough? That's fine. So when everybody's here, Ethan, yell at me every now and then and say, hey, Ebersole. I don't mind. I'm I tried to bend down and. What happens with the X's here?
They're gone.
They are eliminated. That's the whole reason that we name it. What's a negative y and a negative 4y give you?
Negative 5, 1.
4 and negative 4.
0.
Divide both sides, y ends up equaling what?
0.
That's one of our answers. What do we do to find x?
Uh,
Plug this back into one of those. I'm going to plug it in right here. So we got 2x minus 0 equals 4. We really don't need that minus 0, right? So 2x equals 4. That means x equals 2. So what point do these two lines intersect at?
2, 0.
So if I drew the two lines, they might look something like this. They intersect at that point right there at 2, 0. So hopefully you remember systems of equations, because we're going to do a bunch with that. If you haven't grabbed the notes yet, there's 3 piles up here. Grab them. The paper that you just wrote on, make sure your name's on it. You're going to lay it right there. If you have grabbed the notes, start filling this in. Abby, am I getting out of your way enough? You wouldn't lie to me, would you?
Oh, it's color coded now.
Wow, is that fancy?
Yeah.
Don't want pictures of me. Sucks to be serious. What?
Pizza dinner? Oh yeah. I just hope it's not deep dish. What can I ask?
You sharpen your pencil more than anybody having that.
I write so hard. It sounds like whenever you try to open a door super slow.
When you write so hard, it makes the things thicker and it's more messier.
Well, I don't know how to not write. It's hard. So
Just like,
Maybe that'll
don't
fix your
press on the
handwriting
pencil.
too.
Maybe you should use mechanical pencils.
no.
He breaks it.
Every time I place it down, I break it. I can't use it.
Fine.
That's guys with
Different pairs of lines.
It's just special.
Another one that I want you to add to this. We could just have intersecting lines. And we've talked about those already. Intersecting lines. Intersecting lines have to be coplanar. Otherwise they wouldn't intersect. So we've dealt with stuff like this. This is my 2 lines. These could be intersecting lines. They intersect each other. And they would have to be coplanar. So maybe they would coplane on the desk. That's our plane. They're both coplanar to each other. What's coplanar mean again? On the same plane. Parallel lines. Your teacher in the past probably lied to you about what parallel lines were because they told you the wrong definition. Parallel lines are coplanar lines that never intersect. They probably told you what? They just never intersect. That's not the case.
So if you were to connect 2 planes, sort of like this in that corner, right? There you're to have a line over that one, they were and they were to connect to that line that those 2 planes connect, that they through the same plane. Or would that not even be possible?
What do you mean? What are you saying now?
So let's say this wall and that wall are 2 different planes, right?
Right.
They were to connect to a line.
Right.
So if you were to have a line going through that sort of connection between the 2 planes. Okay, and then have one on the other plane. Like not like in the middle, like one from one plane, one from the other. Would that be considered 2 separate planes or the same plane? Because they are connected.
Alright, so they're on 2 separate planes as far as the wall goes,
Yes.
but the walls go, I should say.
Okay.
In our world, is there some other plane that runs like this?
Yeah.
So they would be coplanar. So parallel lines or coplanar lines that never intersect. Your teacher probably told you just lines that never intersect. That's not true. I give you those 2 lines there. So See, she's laughing and I did it on purpose. I give you those two lines there. They're never going to intersect. Are they parallel?
They're line segments.
Right? They're not parallel to each other, even though they're never going to intersect with each other. Because this one's in this plane, that one's in the floor that's our plane.
So they would be a skew line.
So those would be skew lines. Skew lines look something like this. Alright? Can't be coplanar. There's no plane in our world that contains both these lines. But they're never going to intersect. But they're not parallel. Alright, so parallel lines, skew lines. Perpendicular lines we talked about, that's the upside down T. Anytime you hear perpendicular, you should think of what?
Right angle.
Right angles. Give me something else. 90 degrees. Perpendicular lines are intersecting lines that maybe look something like this, and all these angles are right angles. Write down what you need to write down on this one. It's just a postulate. Through a point not on a line, there's exactly one line. Oh, and I should have said this on the last slide and I forgot. That symbol means parallel. So if I write this, somebody read this to me. Line AB, and then read this to me.
Line CD.
Line CD, and if I put this in between them, now it's red. Line AB is parallel to line CD. So that's how you would write it out in the sentence. What if I put this up here? What should you tell me?
You can't do that.
You can't do that. Ebersole, don't be an idiot. Can't say lines are congruent. What's the only things that we know that can be congruent? Segments and angles. So, in our world, through a point not on a line, so we got point A here, it's not on this line. Somebody name that line for me. It's been a while since we did this.
H.
It'd be line, remember use the word, not the symbol, and then the lowercase letter. We're going to do this a lot more, so you've got to be able to do this. Line H. This point's not on line H. How many lines are there in our world that go through this point and are parallel to this line? Just one. That's the only one in the world that's parallel to that red line. These symbols, anytime they put these symbols on there, that's telling you that those two lines are parallel. So this is a symbol if you're writing out in this form. This is the symbol if you're putting it in a picture. Some books might just do this. They might just put extra arrows on it somewhere. Alright? Different books do it different ways. Some of them put these little triangle looking arrows on it. Some of them just put arrows. Just know it means that they're parallel to each other. Through a point not on a line, there's exactly one line. What's this upside down T mean again before we start writing?
Perpendicular.
Perpendicular. So how many lines in our world that go through A here that are going to come down and hit this line and form right angles? Just one. There's only one in the world that hits that and forms right angles there. Now what those two postulates are good for, if you're given a picture or given something like this and some point out here, and we want to go from here to there, we want to form a right angle there. So when Logan does it, and when Jameson does it, and when Dominique does it, should they all draw different lines in for this one? Because there's only one in the world that fits that. All right, so there's only one way to do it. That means everybody's going to do the same thing. On this, nothing to write, there's stuff to write down on this, but nothing to fill in. When you're looking at this picture, the two green lines, first of all, name this top green line for me.
Line A.
Line A, using the word line and the lowercase a, and the other green line. Line B. The two green lines are called coplanar lines. Here in a few minutes, we're going to say that they're both parallel to each other. They don't have to be parallel for some of the stuff that we're going to do to work, but they have to be parallel for us to do a lot of what we're going to do with them. Those two are the coplanar lines. This other line that intersects them both. Here you go, Logan. Now you get a chance to laugh at me, because I won't be able to do it. This other line that intersects them both. I got it. It's called the transversal. Doesn't matter if it's like this, 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 however it looks. The one that intersects the other two lines is the transversal. So this one right here is the transversal. These two are your coplanar lines, or maybe parallel lines here in a minute. The third one is called the transversal. So which line is the transversal here?
D.
Line D. On this, how many angles are formed when I have the two green lines and the transversal?
8.
8, and that's always going to be the case. Notice here, these angles in here are called, they got special names. They're on the inside here, so what do you think they're called?
Inside, interior.
Interior angles. What do you think these angles are called?
Exterior.
Exterior angles. Real difficult. Math people so creative. Interior angles are on the inside of the two coplanar lines. Exterior angles are on the outside. What do you still know about angle 1 and angle 3? They're congruent. They're vertical angles. What do you know about angle 5 and angle 8? They're vertical angles. They're congruent. What do you know about angle 5 and angle 6?
They are,
They're supplementary. They're a linear pair. They add up to 180. What do you know about angle 3 and angle 2? Supplementary. You still know all of that stuff. So none of that changes. On your pictures, every one of these I messed up. Yours says 1, put a 4 in there. Corresponding angles. I don't want to change my transversal, I might confuse Abby. So I gotta keep this one as the transversal. If I have this picture, whether it's up, whichever way, it doesn't make any difference. Corresponding angles. If I do this with all my might and strength, and I make the two coplanar lines lay on top of each other, corresponding angles lay on top of each other. You're not folding it, you're just smashing them together. All right? So which angles in this picture are corresponding angles?
1 and 2.
Say it again.
1 and 2.
Smashing the two green lines together.
Oh, other way.
4 and 5, or 4 and 6. Wait, no, 4 and 3. Oh, wait, yeah.
Does everybody see?
Yeah.
Take this, you smash it down, 4 is going to lay on top of what?
7.
Now again, don't fold it, just crunch them together. So 4 and 7, what else? 1 and 5, 3 and 8, 2 and 6. Those are all corresponding angles, and that's what you're going to fill in there. 1 and 5, 2 and 6, 3 and 8, 4 and 7. Those are called corresponding angles. The other thing I want you to write with corresponding angles here, I'll give you a second to make sure you got those angles down. if I pick a pair of those corresponding angles, I'm gonna pick 3 and 8, and I trace angle 3, everybody agree I traced angle 3 there?
Yeah.
And then I trace angle 8. What did I form? Might write that down, just say form an F. If you trace those two angles, any pair of corresponding angles, if you trace them, it sort of gives you an F. Might be helpful just picking out, hey, these are corresponding angles. Again, put the 4 in place of the 1 there where I messed up. Alternate interior angles. Well, if we're dealing with interior angles, what angles do you think we're dealing with?
Inside.
So which ones are those?
4,
4,
3,
3,
5,
5,
6.
6.
Those in there, right? What do you think alternate means? Sort of opposite each other. And that's sort of what it means. It means opposite corners. So like angle 4 would be opposite what?
6.
Angle 5 would be opposite. Those are alternate interior angles. 4 and 6. Angle 3 and angle 5. The F thing that I showed you on the last one, that's sort of helpful. This is very helpful because we use alternate interior angles a lot. If I trace angle 4 and angle 6. Everybody see that? That's angle 4, right?
Yeah.
Then I trace angle 6. What'd I get? A Z. They're going to make a Z. If it was turned the other way, instead of a Z, it would be a N. If it was sort of spread out, because Jameson's going to see something like this, might make something like a lightning bolt. All right, but they're going to form something like that, a Z or an N. So whenever you trace that, those two angles, alternate interior angles, they form that. Which ones do you think are alternate exterior angles?
1 and 8.
2 and 7.
1 and 8, 2 and 7. As you write that down, if I trace angle 1 and angle 8, will they form together? Absolutely nothing really, right? So I got no cute little ways to teach you how to get those. You just got to know them. Alternate exterior angles. They're on the outside and they alternate corners. Next one, consecutive interior angles or same side interior angles. Different books call them by this name or this name. When I first started teaching, I always called them same side interior angles. Then when I started teaching out of books, once I got here to trail, every book called them consecutive interior angles. Now this book calls them both. So I have no idea. So I got used to calling them consecutive interior over the last 20 years. Now they're going back to the other name that I'd forgotten about from my first 10 years of teaching. Consecutive interior angles. Any guesses which ones are consecutive or same side interior angles? 4 and 5, 3 and 6. Look at these two. The way I remember this one is I call them roommates. Why would you call them roommates?
For the same space.
Right. They're the only angles that don't have a wall between them, aren't they? Everything else, angle 1 and 8, has 2 walls between them. The only ones that don't have walls between them, 4 and 5, 3 and 6. Those are consecutive interior angles. consecutive interior angles. That's an ugly hand sign. I can't even draw it, so. Because you know I would. I sure can't type. You still have vertical angles, you still have linear pairs, supplementary 180. Give me a pair of vertical angles.
1, 3.
1 and 3, give me another pair.
2 and 4.
Angle 2 and angle 4. So on, so on. I'm not going to write them all down. There's a whole bunch of them, right? Actually, only 4 pairs, but give me a linear pair or supplementary angles. 2 and 3, angle 2, angle 3. Give me another pair. 6 and what? 8.
5, 7.
There's a whole bunch of those in there. You still have all those, so don't let, that's not going away. Not sure why I have dotted stuff on there. Stuff that we do today, this is the most important. Before you start filling in everything, what's this first part say?
If parallel lines.
So that means every time they gotta tell you that you have what? Parallel lines. These only work if you're starting off knowing that you have parallel lines. What? You want me to just come over and write it for you every time? Maybe you get tired of writing the same thing over again. When we get to the last one, it's different. So if my 2 lines here are parallel, they have to tell you that. If they're parallel, corresponding angles must be congruent. If my lines are parallel, alternate interior angles like this angle and this angle up here have to be congruent. If my lines are parallel, alternate exterior angles where my 2 hands are have to be congruent. If these lines are parallel, these roommates right here have to be what? Supplementary. Oh, I thought I could trick somebody, but so what's different? This one's sort of the oddball, right? This one says that they are supplementary, means they add up to 180. All the rest of them are telling you that those special pairs of angles are congruent to each other. But it only works if you know starting out that the lines are parallel. The lines are parallel.
Just wrote congruent 3 times. You expect me to get it right?
So looking at this, what do we know about these 2 lines? They're parallel. That's what those arrows tell us, isn't it? So they are parallel to each other. So which angles are congruent? Give me 2 angles that are congruent. Angle 1's congruent to angle 3. Give me another pair of angles that are congruent.
5 and 8.
Say it again.
5 and 8.
5 and 8. 5's congruent to angle 8. Give me another pair.
2 and 4.
Angle 2's congruent to angle 4. Give me another pair.
6 and 7.
Angle 6 and angle 7. If somebody's telling me wrong, please let me know because I'm not even looking. Give me another pair that have to be congruent. What'd you guys do? Just tell me all the vertical angles?
Yeah.
Alright, so you told me all the vertical angles.
4
Now tell me a pair of corresponding angles. One corresponds to which angle? 5. So they have to be congruent. Angle 4 corresponds to which angle? 7. So they have to be congruent. Angle 2 corresponds to which angle?
6.
So they have to be congruent. Angle 3 corresponds to which angle?
8.
So they have to be congruent. Pair of alternate interior angles.
4 and 5.
Angle 4 has to be alternate interior angles.
6.
Angle 4 has to be congruent to angle 6. Another pair of alternate interior angles.
3 and 5.
Angle 3 has to be congruent to angle 5. Pair of alternate exterior angles.
7 and 2.
Angle 7 has to be congruent to angle 2. Another pair of alternate exterior angles.
1 and 8.
Angle 1 has to be congruent to angle 8. Just from knowing that those two are parallel, we know all that information in this picture.
That's a lot.
And that's only about half of it. Name me a pair of angles that are supplementary. 2 and 3, so it's angle 2, angle 3, sorry, that's ugly. Angle 1 and angle 4.
6 and
Angle 6 and angle 8.
8, 5 and 7.
I'm not even gonna list all these. Those are all, there's a whole bunch of them in there. There's even more than we had over here. Name me a pair of roommates, consecutive interior angles that have to be. So these two in here, angle 4 and angle 5 have to add up to 180. Give me another pair.
6 and 6.
Angle 3 and angle 6 have to add up to 180. We know all that information just from the fact that those two lines are parallel. Nothing to do on this one except we're going to draw this. In a plane, if a line is perpendicular to one of two parallel lines, then I left out a word. Then it is perpendicular to the other. So first I'm going to draw a plane. Does that look like a plane? We have a what?
Line.
A line, so I'm going to draw a line. Let's name it. Line what?
N.
So remember a lowercase n out there on it? And it's perpendicular to one of two parallel lines. So I need another line. What are we going to call it?
T.
And what do we know about this angle right here?
Right angle.
It's a right angle because they said it's perpendicular. So it's perpendicular to that one. Then we have a third line.
H.
And what do we know about that third line as far as this line goes?
Right angle.
They're parallel, so let's mark them as parallel. And if those two are parallel, this one's perpendicular to that one, what has to be true about these two lines?
Also perpendicular.
They're also perpendicular, that's all this theorem says. Probably didn't need to draw that, I think I made up a picture. Now I gotta go through all this motion. What's these arrows tell us about those two lines? They're parallel to each other. This line is called the what? Transversal. And that's one T. I think I changed the names on it. If that one's a right angle, what do we know about the other? Right angle. Find all the angles. I think this is one of the examples there on your picture somewhere. We know these two lines are parallel. This angle is 112. Tell me another angle that you know.
5 is 112.
Fill it in. What else?
1 and 3 are 112.
What is it?
1 and 3 are 112.
Angle 1. How come angle 1's 112?
Because it is. They're all because I say. When they're smashed, they're on top of each
So
other.
those are our corresponding angles, right? So that's 112. Angle 4 is 68 degrees. Everybody agree with that? If angle 4 is 68, what can you tell me about angle 6?
All the other ones are 68.
68. Those are alternate interior angles.
That's actually really easy.
What else? 3 is 112. 68, 768.
They at Logan.
That was last year. Okay.
No,
No, that was this year.
I've been dropping it this year.
So if I just give you that straight out picture like that, it's not very difficult, all right? Everybody should be able to find all those angles given one angle if I just give you a straight out picture that way. How about this one? Find this one on your paper. What are we going to do on this one?
Bottom.
We can find some of the angles, right? Which ones can you find?
565, 665.
So we can find those because we know vertical and supplementary angles, right? What do you know about angle 5 and this angle? They're the same. So x plus 5 should equal what?
65.
So x equals 60. You can find that. I should have put up here find all angles and find x. Why did it do that on me? What's angle? This angle, what is this angle? How much? 65. 3 is 65. 4 is 115. 115. Now, once we do all those easy ones, and Logan's already looking at it, I can tell what's going through here. Ebersole is just exactly the same down here as it is up here. You just transfer it up. And that's true if you just have something easy like this.
Oh, I just sold it.
We go to the next one. This is where everybody gets confused.
Mr. Ebersole, you had to do this. You could have just looked easy.
They tell us angle 10 is 60 degrees, so I'm going to write that in right here, 60 degrees. They tell us angle 7 is 50 degrees, that's right there. Remember, this is red. Measure of angle 7 equals 50 degrees. When you're looking at a picture like this, notice, did I ever show you anything that had two transversals in it?
Absolutely not.
No, because you can't have two transversals in the picture at the same time. So what you have to do is, if there is two of them, you need to get rid of one of them so that you just have one, so you can deal with that easy picture like we've been dealing with.
Oh.
All right? So what I'm going to do on this is I'm going to pick either the red or the blue to be my transversal. The two green lines are my parallel lines. I know that. Which one do we want to use, red or blue? Red. So the red's going down through like this. This is angle 1, that's angle 2, that's angle 4, that's angle 3, right? Correct? Now here's where you got to be careful. This angle is how much? 50 degrees. How much is this angle right below it?
Wait,
You don't know, do you?
no,
Is it just 60?
no.
No, it's 60 and the 9 together, isn't it?
They're just 70.
So we don't know that, so we'll have to come back to it. On this other side, this is angle 8, but this is angle 5 and 6 together. That doesn't mean that it equals 11, all right? So we don't know that one either. But can we find all of these angles?
Yes.
Yeah. So tell me an angle that we know. If this is 50, angle 8 is 50, 3 is 130. What else? Say it again. 1's 130. 2 is 50. 4 is 50. What's this angle right here? 130. Even though that's not one of our numbers, that's 5 and 6 together, right? What's this angle where I got the question mark? So now we have all that. We can fill in some of them, like 8 we know is 50. 1 we know is 130. 2 we know is 50. 4 we know is 50. 3 we know is 130. Can we fill in anything else now?
Which is hard.
5,
What do we know about 5?
it's 60,
60, how come?
because it's vertical.
Those are vertical angles?
9 to 70.
70, because these three angles gotta add up to be how much?
180.
180, so it's 70. What else do we know?
6.
6 is 70 also. Now what we do, we take the two parallel lines again. And this time, instead of picking the red line as our transversal, we pick the
Other one.
blue line. And you gotta be careful again. How much is this angle right here?
No. It's just those two.
So it's 120. How much is this one over here? 60. How about this one up here? 120. How about this one? How about this angle right here? 120. How about this angle? 60. How about this angle? 60. How about this angle? Now can we go over here and fill all these in? Notice, did they all come out to be the same like they did on the others?
No.
No, they switched up. Crook problem. On this crook problem, real quick, we're going to do this very, very quickly. On a crook problem like this, these two lines are parallel. Is this red line a transversal?
No.
No, because it's crooked. That's why it's called a crook problem. All we're going to do is we're going to draw this.
Add a third line.
Add a third line. And we're going to say, because we had a theorem that said we can go through this point and there's only one line in our world that's parallel to this line that goes through that point. So we know that all three of these now are parallel. Looking right here, if that angle's 29, what's this top part of angle 1? Forms a Z, so those are alternate interior angles, right? What do we say about alternate interior angles? They gotta be the same. Looking down here, what kind of angles are those two to each other?
Same thing.
Same thing. So what's this angle? 26. How are we gonna find the measure of angle 1? Add those two together. What's 29 plus 26?
45. No, 55. I forgot to add.
Gotta remember, Z forms what kind of angles? Alternate interior. At the end of those notes, remind me where we left off next time. These are all just examples. At the end of the notes, there's an assignment. That's your assignment. And there's another part to your assignment.
Pardon me, teachers, for the interruption. At this time, if I could have the National Honor Society students.
Did I get everybody's paper from
Please report
earlier?
to the smart room. Thank you.
Don't forget to do my extra one.
You're going to, another part of your assignment, you're going to grab this paper right here. If you do it, it's going to be added points back to your test.
I beat that.
Points added back to your test.
You better do my extra point. It's the same one we did.
Who else was it? Ethan.
I worked hard for that assignment.
Ethan, I'll remember.
I worked hard for that.
Can I take that paper down?
You better remember mine.